Hello, and welcome to another video from Ellensburg Amplifier Repair and Service. My name's Todd, and here we have today a Phoenix Gold amplifier. This is probably one of the newer versions of their amplifier. I don't get a lot of Phoenix Gold amplifiers in. I get the older titanium series in, and the ones that are in the white case. So I don't remember what series that is, but I think this is a newer line of the Phoenix Gold amplifiers, as long as this isn't a knockoff of a true Phoenix Gold. But this is the RX2 1000.1. This is a mono amplifier, and I figured I would shoot a video on this because I have not covered, I don't think I've covered any Phoenix Gold amplifiers on video. So I figured, why not? Let's do this one. So I have already removed 2 transistors before I decided, oh hey, let's shoot a video. So this is the back side of the board for you, as I removed these 2 output transistors. These are the IRFP 4321 transistors that I have fresh from Mauser here. All right, these are the 4321s. It uses a 2957 output IC. And it also has, I noticed, it looks like they're using 2 gate drivers. So I don't know, this is the 2045 gate drivers. I think they're gate drivers. Yeah, it's a different kind of driver than I'm used to seeing. Oh, hold on. The 2045, I think that's a transistor. I'm not sure. Looks like it's coming off pins 9, 10, and 11 going into the 2045. It's a 6-pin IC down here. I'm gonna have to do some digging, and as long as these aren't shorted, or if they are shorted, I'm gonna have to do some digging to see what these are. But they're right here. There's a little 6-pin driver chip here and a 6-pin driver chip right here. So these are like the 6-pin drivers, the the ZXDG 3003s, 3005s, the same style, but I'm not used to seeing the 2045. I'll have to dig into that if there's a problem here. So what I'm going to do is I'm just going to see what I have for shorted output transistors. If I remember right, when I initially checked this for the quote, that I did have shorted outputs. Yes, so this is shorted. And let's check this one. So the other one's not shorted. So we had 1 shorted transistor. But I ordered 2 new transistors for it. Even though they're not a parallel bank, I'm just going to go ahead and replace both output transistors for 2 brand new transistors straight from Mauser. Let's open it up, see what we got here. So the 2 transistors from Mauser are right there for you guys. They do have the same date code on them. So they are I don't say matched pair, that's technically incorrect. But they have the same date going on, the PP78 IRFP 4321. Now my next step is I want to see if I have any shorted gate drivers. Because if I do, that's going to pose a little bit of a challenge to repair this, because I do not have a driver like that, or if it's like a dual transistor, I just don't have these. So I'm just going to do some readings here real quick. So I'm reading 11 ohms, which is going to be correct because we are, looks like we have two 10 ohm resistors. Let's see here. Let me see what we got going on here. Yeah. Oh, there it is. So we have a 10 ohm and a 1 ohm. So one must be a pull down. So we have a 1 ohm resistor, excuse me, in series with a 10 ohm resistor going off to the gate of the transistor. That's an interesting setup. I'd be interested to see what kind of IC that is. I'm just going to do some resistance checks here just to make sure that I don't show anything shorted. So far, I don't. I don't see anything shorted. Let me check the vias here. Nope, I don't show anything shorted. I wonder if I were to apply power to this, if this board would give me some pulses. Let me just do some quick checks here across the 1 ohm resistors. Yep, 1 ohm and 10 ohm. Robust. If this survived a shorted output without damaging anything else on this circuit, I'm going to call this circuit robust. So what I'm going to do is I'm going to go ahead and flip it over, and we're going to put some power to this and see what this thing is doing. It's pretty obvious you can't start an amplifier if you have shorted outputs. It'll just go and protect. What are all these switches here? Base EQ. Well, we're going to set that to 0. All the potentiometers are fully counterclockwise. Let's get some power. 10 ohm. 10 ohm. 10 amp. Current limited power supply here. What I didn't check is to make sure that I didn't have any shorted power supply transistors. So usually, a lot of times when you short the output, it will do some damage to a power supply due to the load that's going to go across it. 19K gate to source, 19 gate to source. I do not know the topology of the drive circuit for this. Again, it's not very often that I get Phoenix Gold amplifiers in, especially newer styles. This was made in 2018. Hey, there's a date here. So yes, this amplifier is 1/3 of 2018. It's the RX2 1000.1. I don't show any shorts across the power supply. Board's a little dirty. Never fear though, like you know me, I will keep it clean it up. Let's go ahead and turn the power on, see if I got any shorts on the power supply transistors. Nope, no shorts there. I'm just going to find the LEDs. Where's the LEDs? Oh, right here. So power blue, protect red. It's a 3-stage LED. And let's see what this thing is doing. Get my probe here. I'm set at 50 volts. I'm going to go down to 10 volts. And my goal is to see if I have any pulses on the gate here. Oh, and I saw that. Goes to ground. Oh, I do see some pulses. So that's going to ground, and we're at 10 volts at a division, so we're at 50 volts right now, so I'm going to have to bump my voltage up a little bit. The rail capacitors on this are 80 volt capacitors, so I don't expect to get much higher than about 73, 70 volt. No, it's not too bad. 61 volts. The red light comes on, and I'm just getting some pulses on the blue light. Excuse me. Am I going to need a signal for the 2957? Just in case, what I'm going to do is I'm going to hook up a signal to the amplifier. Two volts input signal at 50 hertz. Because I don't know if it needs a signal. Oh, but there is a pulse on the low side gate. And of course, I'm not going to see it on the high side gate. I'm going to bet money that if I put a output transistors back in place, that I'm going to see something come alive. Yes, I do get a pulse. Excellent. And we are at 62 volts. And it's holding at 62. Do we not have discharge resistors on this? This goes back to safety, guys, when it comes to working on amplifiers. You just never know, if you're not familiar with the design, if there's going to be discharge resistors across the rail capacitors. As I always say in my videos, at the end of every video, is I always say keep your fingers out of the rails. So right now these rails are charged at about 60 volts. And holding, yep, 61 volts. Which is telling me that we probably don't have discharge resistors. Now the odd part is my positive rail is at 20 volts and dropping. So I have discharge resistors across the positive rail, but nothing across the negative rail. Now that's interesting. Yeah, it's 60.5 volts on the negative rail, and the positive rail is down to 16 volts. Well, we're going to have to discharge these rails. Let me find my leads to my discharge resistor here. There it is. This is how you discharge. This is how you discharge rails. So we're going to go positive rail, negative rail. A little bit of a pop there. So these things do hold a little bit of current there for you. Again, we call those bad day makers. I am going to fire up the Hacko FR301 desoldering gun to resolder new transistors in. And I'm just going to kind of gauge the length of the legs here for the proper positioning of the placement on the heat sink. Now I can see where the at the factory they actually marked the legs of how far they should be down on the board. Which is an excellent idea. I used to do that quite a bit, mark the legs for height or depth, but after you repair amplifiers of the same type so many times, you actually start to go by feel. Well, at least I do, about how far the transistor is placed into the via. So I discharge the rails just so I don't do any damage to the transistors going back in the board. You always want to make sure you don't have any power on your rails when you're working with transistors. Because remember, even static electricity can turn a gate on. So I'm just going to go to my mark. And I'm going to solder the new transistors in place. And I hope everyone is doing well. It's staying cool. This is summertime of the recording of this video, and it's supposed to be like 109 today, so hope everyone is going to be doing good in their area of the world. So there's the output transistors reinstalled, brand new, straight from Mauser. One of my go-to places. Will it work? I have no idea. We're going to find out, though. So hook the power back up, turn the power back on. And we are going to check the power supply here. Oh yes, fires up. So we're going to check the gate, see if I get any switching. And we do get switching, and a blue light. Well, that is what we call super fantastic. I'm just checking here with my fingers to make sure I'm not getting any overheating. They're still just a little warm from the soldering, but I don't suspect that's going to be from the drive. They could. Nope, stays nice and cool. All right. So let's just show you, I don't have the scope on the screen for you guys. I am slacking. Sorry about that. Let's go ahead and fire this scope up. If I can find it. USB, search, Rigol, DS, Z series, and select. And there's the scope for you guys. Just to show you that this is up and running again. All I did was replace the output transistors. Didn't show any shorts on the bottom side of the board of the drive circuits, so I felt confident enough to put the transistors back in place. And there's your drive for you. There's your high side, your low side. Let me there's my UT161D beeping at me. Let me widen up this time base here a little bit here to show you guys the actual signal of the drive. 50, I think, is it 50 microseconds, 20 microseconds? I don't have these things memorized. So 20 microseconds. I gotta use a couple different hands here. I'm gonna get the trigger down here for you. So there's the low side drive. And then your low side drive, which basically drives your high side drive. And there's your high side drive. So just a quick rundown on the quick repair. Literally took me probably 15 minutes for this. Checking the drives, checking for temperature, and nothing at all is getting warm. Nothing's heating up. So this is good to go back in the heatsink. And of course, go through full testing. So I do thank you guys for watching again. Just remember, amplifiers, like the positive rail here, does discharge slowly, but the negative rail stays charged. So you never know, there's some potential here. Keep your fingers safe, stay out of the rails, double check everything before you start working on these. If you don't know anything about electricity and you're working on big amps like the big 15, 20, 30K amplifiers, just stay out of them. Talk with a professional. Thank you guys for watching. We'll catch you on the next one. Stay safe.